Okay, so today we're going to continue with law of sines, and this time we are going to find missing angle measures. So just remembering the law of sines says that the sine of the angle is equal to the side length across from it. So I could say that the sine of angle T over RS is in proportion with the sine of angle S over RT. And since I actually have numbers for each of those, I can plug them in and look at what that looks like. So the sine of 74 degrees over 12.3 is equal to the sine of angle S over 12.7. Now we're going to do some algebra, and then we'll use our Desmos calculator to actually solve. So the first thing I do is cross multiply. So that becomes 12.7 times the sine of 74 degrees is equal to 12.3 times the sine of angle S. Well, I want the sine of angle S to be by itself, so I'm going to divide. So I'm going to divide by 12.3 on both sides. So what I am going to have to find is the inverse sine, because I'm going to have to solve this particular equation. So let's go over here. So I've got the sine of angle S is equal to 12.7 times the sine of 74 degrees, all divided by 12.3. Now remember, when we solve, we take the inverse sine. So I'm going to take the inverse sine on both sides. Those are going to cancel. So in order to get S degrees, S is going to equal to, and this is the tricky part, the inverse sine of 12.7 times the sine of 74 degrees, all divided by 12.3. I can put that in all together in one foul swoop on Desmos, okay? So I can do that all on Desmos, but you do have to be careful. I would not recommend using a cell phone calculator to do this. You can also use a TI calculator. That would probably work really well. So let me show you what it's going to look like on Desmos. So here's my snip from Desmos and what it looks like. I will say that I did have to take the time to close this parenthesis and then do my division, and then when I was done to close the second parenthesis. Okay, so that will help. It will generally want you to round this to the nearest degree. And so if I round this to the nearest degree, that means that angle S is about 83 degrees. Or up here, it's about 83 degrees. Now, we could use the law of sines to find angle R, or we could remember that all of the angles in a triangle have to equal 180. So angle R is really the same thing as 180 minus 83 minus 74. And when I use my calculator to solve for that, I end up that angle R is equal to 23 degrees. So it doesn't really matter which one I start with, as long as I end up with the two angles, I can always find the third angle. Now, if I wanted to find ST, I could use angle R and the law of sines in order to find ST. So if I were going to do that, I would do that the sine of 23 over ST is equal to, and I would use what was already given, so the sine of 74 all over 12.3. And then we would cross multiply and solve. We would not have to use the inverse because we are not looking for an angle. The only time we're going to use inverse, sine, cosine, or tangent is when the angle is the missing piece. So when the angle is the variable, when I'm looking for an angle, I'll use the inverse. Otherwise, I won't use inverse.